Good afternoon and welcome to the Construct Innovate webinar series on digital construction technologies. This is the final week of the webinar series. This week we're going to concentrate on digital buildings and communities, where we have three speakers this morning. My name is Jamie Goggins and I'm Director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. So our three speakers that we have today is Jaan Saar, who's the Chief Evangelist from Future Insights. And he's going to talk about some tools that they have developed around BIM and urban data management. Our second speaker then will be Christopher Robin Raitviir, who's head of digital construction in the city for the city of Tallinn, and he's going to show how some of these tools are being used within the city of Tallinn to make decisions in terms of planning and development within the city. And then we have Ian Pyburn, who's the senior business development manager from IES. Who's going to discuss how digital twins can bring net zero buildings to the next level. So if you have any questions for our speakers during the presentations or afterwards, please put them into the Q&A function that you see at the bottom of your screen. We'll have the three presentations first, and then we'll take the Q&A afterwards at the very end. So without further ado, I'm going to hand over to our first presenter, who is Jaan Saar from Future Insight. Over to you, Jaan.
Thanks for the quick introduction, and it's an honor to be on the webinar to present and talk about BIM and urban data management. And well, actually, our focus, or my focus, is also BIM-based permits. So we agreed with Christopher, who's following my presentation, that he will focus more on the planning phase, and that Tallinn is really looking at in detail now. And maybe I will cover a bit more of the building permit stuff. But yeah, to get things going, a little bit about Future Insight. So Future Insight is a young company, 10 years old, and we develop online solutions for the construction industry. And I joined Future Insight about a year ago, almost, so in February of this year. But before that, I was working for the Estonian government, actually together with Christopher. So that's why I know him really well, and it's nice to be in a webinar together with Chris again. And as I said, we develop smart online solutions, and we focus a lot on open standards in the construction industry, but maybe a little bit more about that later on. Here's a nice picture of our team. So we're not a big company, we're quite a small company, so less than 30 people altogether, but we have a very, I would say, unique set of skills and experience when it comes to especially combining BIM and GIS knowledge, because a lot of these kind of, how to say it, there's different kind of approaches from the geo information side and from the building information side. And often they don't speak the same language, or there's different formats and it's difficult to convert. So, but what we have is really a combination of both. And we have developed some cool technology, which I'm going to share a little bit with you as well. So our three main or four main products here are clearly projects, which is kind of a workflow management tool together with all kinds of geospatial information put together, so you can track and monitor issues and approvals, environmental aspects for mostly large-scale infrastructure projects. We do digital twins. The 3D visuals of digital twins. We provide infrastructure, the service, for example, for Rotterdam, who's been a client for a long time, but also other municipalities in the Netherlands, like The Hague, and Groningen and others. But yeah, and this is something Future Insight has been developing as well for a long time. Clearly, BIM is what I will focus on today, which is our solution for doing advanced compliance checks for BIM models, but it's actually more than that. So it's not just about building permitting. And clearly Hub is our latest development, which kind of brings everything together, the data and the services on one platform. But all in that in more detail. But maybe before we go into the solutions themselves, or describing why we're doing this stuff, maybe a bit look back at the bigger picture, the large challenges that all the municipalities I think everywhere are facing, in Ireland, in Europe, and across the globe, actually. One of them is, of course, the lack of housing, especially affordable housing. And there is a housing crisis, I would say, everywhere. So we really need to figure out how to build better, more efficient. At the same time, we're faced with urban changes, requirements. The cities themselves are undergoing transformation. I mean, what is the homework balance? How and where people want to live, and the more and more emphasis is put on smart city planning. So how to take advantage of that, and at the same time, we're going through energy transition, which is having a huge impact. And the final one is, of course, the digital transformation. So how to not be scared of digital transformation, but really embrace it and see what it actually can help us with. So, of course, we focus on the digital part, and you probably heard this quote that data is the new oil. But in addition to having just being the new oil, you also need to find, extract it, refine it, distribute it, and monetize it. Just like with oil, because I don't think anybody really has crude barrels of oil in their garage. And the same thing is with data. You hear a lot of people talking about, okay, data is really important. It is the new oil. It's valuable, etc. But data in its pure form is relatively useless. So you really have to know how to handle this data. And in our industry, it's kind of I can draw a equal sign between BIM and data, because in the construction industry, building information models provide a lot of the structured data that we can use within the whole lifecycle process. So the question is really about how to make your BIM data more accessible, refined, and distributed, and where to start. And when talking to a lot of municipalities and governments across Europe, I often see that although we have kind of advanced tools to do, we can do automated compliance checks, that's not the first place to start for many. What you really need to start is you need to get the basics right, learn to walk before you run. And that's why you should really start. And I'm using the oil analogy here quite a bit. Just like with oil, you first need to access it. You need to find it, and you make it available. And with BIM data, it's the same. You need to have a way to make it accessible, to share it, and to integrate it with the geo information systems, all the maps and the layers. And it would also help if there's an API, so you can access all of this online. And from my point of view, it's always doing it online in the cloud is where you should be doing. And I understand there's also some security concerns with that, and not everybody's comfortable with that, but I think there's really no other alternative for the future. So once you've made it accessible and you can share this valuable data that you're getting, you need to make sure that it meets your quality requirements. And that's where the refining process comes in. So because the next step is really about automating everything. But if you automate information that is, well, to put it simply, is a mess or a chaos, then what you're left with is an automated mess and an automated chaos. So that's why an important step is to really think about what are your requirements for the data, BIM requirements, how do you validate them? And there's a really good standard from Building Smart now, information delivery specification, which you can use, an open standard that you can use to describe your requirements and also check against them. And then when you have made your BIM data accessible, you've managed to ensure that quality in the BIM models is what you're asking for or what you need. Then is the right time to start automating. And you don't have to get everything perfect in the right away, but you just have to keep all of this in mind. If you're not thinking about how to access and share the data, or how to make sure that you're validating the data before starting automation processes, then you will have a much harder life. So trust me. And this is approach we do also at Future Insight, and what I have followed actually also when we worked at the ministry in Estonia. And beyond that, if you think about just a specific use case for automating, for example, building permit checks, but if you have this BIM data available, then it opens up a whole world of possibilities that you can use it throughout the building lifecycle in all kinds of situations and all kinds of use cases, not just related to maybe construction or planning or development, but also, all material passports. We're talking about maintenance data, renovation, etc. So all this stuff now all this data becomes available to a platform approach, or is viable for it. And that's where you really get the best value out of BIM, I would say. But the idea is not to start with, well, this whole big picture right away. I prefer an agile approach. So that's why you should take it step by step, but you can move real fast, and you can actually get to the platform approach quite quickly. And this is just a picture I like to show to illustrate what usually is going on related to built environment data. So it's always in some disconnected software silos, solutions, information is exchanged chaotically. So this is what we see in a lot of municipalities and big organizations. And that's why we actually started the development of the Clarity Hub, which brings together, it kind of helps you organize, catalog all of your data. It takes care of the governance, the user management, the security, and it also allows you to connect with apps. So in this picture, you see that on the very bottom, you have the raw data, files that are collected, and the platform doesn't store the files. It's not a storage solution. So the idea is that the data remains at the source, so we can use and get the latest updated data from the source. But you still need to catalog, you need to structure all this data, and you can link it to apps, and you can really build on top of this platform. So I've filled some of the blanks with some solutions like clearly 3D City. You can have like CO2 footprint calculation. And in many cases, the services themselves also provide data to the platform. But this is something I can maybe show you in a small video, some examples. And we're piloting this hub approach in the DMI ecosystem, and it's where it's called the Open Urban Platform. And there's a lot of municipalities, a lot of companies involved, and we were seeing really cool use cases being developed for that. And I have a nice video here. So let me just quickly play it. Hopefully it plays fine. I'm always wondering what happens if I push the full screen button during the presentation. But okay, here you can see kind of the hub has a built-in digital twin viewer, which all the teams, which are called kind of hubs, can configure based on what they need. And here is the data catalog. So it allows you to filter, to search, but there's no limit to the amount of data you can actually put in this catalog. But to put data into the catalog, you have to define what it is, who's the owner, etc. So you have to take care of the metadata related to that piece of data. And you can, for example, here's a tree example, here's the metadata about the information. It shows the actual source of the data, etc. So because time is limited, I'm maybe gonna skip ahead quickly. And here, for example, the value of the platform is when you really can combine different data sources and you can view data sets together to, of course, make better decisions in the end. Here's an example how you use heat stress simulation data coming from one application, and we combine it with the 3D City view in Rotterdam. And it makes it available and accessible to everybody in the organization. And it's not that complicated to use, like a special BIM authoring tool, which are often quite complicated. Another use case is, for example, the housing corporation in Rotterdam. together with the fire safety guys, they wanted to have specific views on the buildings, simplified views to buildings to see where they can access, where they can connect fire hoses and where the staircases are. So again, with clearly Hub, with this kind of platform, you can create a use case and you can have very specifically configured, fine-tuned views on the data that is otherwise accessible to everybody. And yeah, and everything's API based, of course, and there's many more use cases we're developing. But this was just a quick preview or a sample of some of them. So yeah, okay, so now let's move on. So BIM-based permitting. So this is a topic really close to my heart because we implemented this in Estonia already some time ago. Why you need permits? They're often quite annoying, but you still need permits to ensure safety, legality, and efficient use of resources within construction. And when it comes to permitting, it's also, you know, if you look at construction in general, it is a very, what's the right word here? It's a fragmented industry. So you have a lot of, and it's very project-based. So all of this information is kind of there, but it's not really centralized. It's not flowing through specific processes. So, but there's always one stakeholder, like the government, the local or the central government, who issues permits, approvals, and information is flowing through them. So that's why we also started in Estonia, was we saw the potential for this. So we started developing the e-construction platform, which is kind of like the hub we have developed at Future Insight now. Only that was very specific to Estonian e-government. But the idea was that if the government is involved in these processes, they should also take advantage and make it accessible for others. But still, building permitting usually is expensive, time-consuming, complex, and usually you just put more money and people try to solve the problem, but it doesn't really help. So what is a better way? So the BIM-based permitting and automation is really, I think, a no-brainer because it, on one hand, it automates stuff, so it makes it faster, so we can automate a lot of technical checks. We improve the quality of the designs because whatever ends up on the desk of the officials doing the checking will already have passed some pre-checks. And there's also transparency because if you automate something, it becomes more transparent. And I do know I'm running out of time, but I just wanted to give you a quick preview of the process itself. So it's a self-service platform based on Estonian example. Where you have the government system and you see the buildings in context with the digital twin. And you can, it's a very simple web-based viewer that you can use to view. You can see it with the surrounding elements. You can do some measurements. You can take off floors. And but it has to be simple because we wanted to keep it really as simple as possible. But the real power comes from the automated checks. So for example, here is a check about door openings, I think, whether or not the doors open the right way. There's another check looking at whether or not each apartment has an entrance from a public space. So a lot of this can be automated and you can visualize it together. You can go down into the details or look at accessibility checks, for example, whether ramps have the right inclination, whether stairs have handrails or whether you can hit your head somewhere. We can also do these advanced geometric checks, algorithmic checks, or for example, the evacuation route length. And this is really important for fire safety guys, of course. And you can add comments and you can send it back to your BIM team. So it's quite flexible how to do that. We also did a project in Finland, but I don't have too much time to show it here today, so I'm going to skip that. Yeah, of course, nice pictures that it's not only me talking about how great the solutions are. We also received Building Smart Award for technology. some quick lessons learned. So I'm just going to wrap it up in a minute or two. Choose the right checks, because legislation is written by humans for humans, so it's not always easy to check it or to make it machine readable. Sometimes you have to change legislation, so be smart about it. The requirements for the BIM models need to be kept really easy and simple. And you should work with open standards and not think about, I need open source solutions, because that's only going to make also life harder. So I think really the private-public partnership here, where private companies develop solutions and also public companies can then get the benefit fast and easy. And by using open data standards, you ensure actually vendor neutrality, because the data part is the most important part, which you should be able to keep, own, and distribute as you wish and as you want. And that's what open data standards provide. And 30 BIM is the solution we have. And next up, Chris is going to talk about the cool proof of concept we did on planning. And some more links to certain activities around these automated building permitting, BIM-based permitting initiatives that are happening around Europe. And just as a final plug, in December of next year, so within a year, we're going to have another conference dedicated to digital building permitting, done together, organized by the EU Network for Digital Building Permits. And it's going to happen on the 2nd to 4th of December in Vienna. So save the date, and I hope to see you there.
Thanks, Jan. Okay, so we're over to our next speaker, Christopher, who's going to talk about this urban planning or digital urban planning in the city of Estonia, to show how the municipality there have implemented it. As I said at the start, if you have any questions from any of our speakers, please post them in the Q&A function at the bottom of your screen. So over to you, Christopher.
Hello, everybody. My name is Chris Raitviir, talking about information model-based urban planning, specifically the prototype we did in Estonia for the city of Tallinn. So a little bit about myself. I'm at the moment working for the city of Tallinn, which is the capital of Estonia. I'm the head of the digital construction there, and also doing my PhD in Tallinn University of Technology. And my main topic there is the synchronization of information flows for the construction lifecycle. Also, I'm quite active on the international working groups like European Network for Digital Building Permit that Jaan also mentioned. We'll have the next conference next year in December. And also I'm at the moment a steering committee member at the EU BIM DAS group. My background is in civil engineering. There I have my master's degree, and I'm really identify myself as this kind of like enthusiast and believer in BIM-based processes. So, but looking at the bigger picture, like why are we digitalizing the things? What is really the purpose? Actually, and the purpose is to create the best place to live in and desired destination to arrive to. So we want to create the best possible environment for all of us. But when we are doing it, and specifically when we're like thinking about the urban planning, these kind of like architectural competitions, so what is really very similar with this picture and all these kind of 3D renderings you see from architectural competitions? Everything is green, it's summer, it's nice, it's the best possible weather. But what happens if it snows? We have a time of that in the year. I don't know about Ireland, most probably not that much, but in Estonia we have like 3 months that is totally white, sometimes gray and black because snow gets polluted as well. We must consider the climate when we're really planning our urban environment. And sometimes in November, October, March, April, it's quite dark, it's rainy, it's not that nice and green, but people are still using the environment. And when we're doing this kind of urban planning, we must really consider the climate because the purpose is still the same. We have to create the best environment for all of us. But where is the problem? If you see there is QR code, you can scan it. Otherwise, after this presentation, I guess you will be shared the PDF as well, where it is. It refers to my first published article for the PhD, where I have analyzed this problem a little bit lot. So there is a little bit more background information. The problem is that the information flow when going from the master plan level or detailed zoning plan level to the construction design, then to construction, and then to maintenance. There are a lot of information drops at the handover of each process. And even if we digitalize all these kind of processes and we don't think of the interoperability, then we will have digital workflows, but they are still the fragmented workflows. But we need to dwell towards the digital synchronized workflows to really get rid of these kind of information drops that are really annoying and need this kind of like reinserting the information that we already have at some point. And how we're managing this kind of like solution in the city of Tallinn is that we are trying to look at the entire building life cycle. So starting from the detailed planning, also looking into the master planning phase a little bit, but then going to the construction design, everything that we're building ourselves, we have the BIM requirements for that. We have the requirement that every building built by Tallinn needs to get the building permit in the BIM permit phase that opened for public in the February this year that Jaan was talking about, this kind of BIM-based building permitting. Then I really hope that the ministry will also do this kind of like very quick module for the BIM-based occupants of certificate of occupancy, aka the usage permit. And of course, we are combining this kind of like BIM data with the GIS data in our digital twin for the Tallinn, so that all these kind of like life cycle processes will be covered, and starting to utilize the BIM for the facility management as well. Now back to the starting point, the urban planning. When we are really, at least in Estonia, when before we want to do start developing the construction site, we need to have this kind of like detailed plan for the construction site that is in accordance with the city's master plan. And this is at the moment quite a long process. What will be produced is the PDF and doc formats. For example, this kind of like visualization as the drawing and like 50 pages of explanation what will be planned in that region. There is no machine readability, and then people who are involved in participation, they have to express their opinion based on these kind of materials. And I wouldn't call it user friendly. I would say this is like extremely perfect example of user hostile participation, because there are like hatches on top of hatches on top of hatches in these drawings, and it's really difficult to understand the information that is really going to be developed there. And then when we're thinking back to the goal, the best urban environment, is this how we can arrive to this goal? Most probably not. And now a little bit bigger picture of this kind of like detailed zoning planning window is that in the top left corner, we have the area that we are planning, that we want to develop. And most of that drawing, like I would say 60 to 70% of this is just a legend how to read this drawing. So it just adds complexity, and none of that information is reusable in the other pages. So we're thinking about this kind of thing. How can we move forward? And one of the answers would be the spatial planning information model. We can call it like BIM-based planning, but rather it would be information model-based planning. But this is not this kind of term that is so popular in the world as BIM. It's not investigated enough in the scientific realm as well. And therefore, when we really want to adopt this kind of like thing, we have to define the scope and the detailed content of this kind of term. What will be modeled? What will be still drawn? What do we have to represent in 2 dimensions? What in 3 dimensions? And what is the level of geometry that we have to produce? And what is the level of information that we need to attach to every geometrical element? Because we're talking about the information model, not just the 3D model. It is extremely important that we are using common open standards and the data content requirements, because otherwise we are vendor locked with some kind of solutions. And again, the data is not interoperable, because the open data is the key. And of course, we want to reduce the time for the detailed planning, but the question is also, are we just faster, or are we making also the best possible decisions to, again, to arrive to the goal to create the best possible urban environment. So we had some kind of pilots, for example, Estonia National Broadcasting Building. We added this kind of like buildable area layers and the building layers and greenery to the existing city model. At the moment, we have this kind of like texturized meshes there. But by the end of this year, we also have semantic models that also have the texture. So it's not only meshes around, but realistic looking buildings that also have the information attached to it. And then again, there are some areas that entire area is being developed. Like for example, Tallinn Harbor area, there are 7 or 8 detailed plannings that are in the works at the moment. And this affects quite a big area in that neighborhood. And then again, when we want to really see what is the impact of these designs by just comparing the PDFs, then it is a quite impossible task to do. But when again we have these main layers as the information models, and we are inserting them to the city model so that it is accessible and everybody who is involved in the process can see what it looks like, what information does it contain, and how is it really affecting the environment, then it's much better for the stakeholders there. And again, when we have the information there, we can do a lot of analysis that can save quite a big amount of money in the later stages. If we are doing wrong decisions in the first hand, then it's going to be more expensive. For example, simple insulation, the daylight analysis, that which part of the buildings will get enough direct sunlight, and there is this kind of like 2.5-hour requirement. And we can see from these dark blue spots that there are spots in the buildings that will receive basically 0 to 1 hour of the sunlight. And if the developer wants to develop their apartments or other kind of like living facilities, then it will be quite impossible. And they have to consider already, and they can consider these things already in this stage, because it's easier and cheaper to play around. Again, we can see due the noise analysis, how many decibels of noise will be there regarding the information of the transportation there. And also the wind analysis, either the 2D, 3D, and see what kind of winds are the most dominant and how shifting the volumes will really adjust this kind of like environment. So for example, if we are walking by the seaside and most of the year it's quite cold weather, then we really don't want it to be very windy in this kind of boulevard that we are walking all the time, and it's quite easily changeable. Now, trying to speed up a little bit, talking about this kind of solution that we were developing together with the Future Insight, was also that when we were doing the detailed zoning planning, they have to be according to the city's master plan. So we want to check different geometrical and semantical contradictions, what is allowed by the city's master plan and what is presented in the detailed zoning plan. And this kind of like automated rule checking and validation offers us very quick solutions. I will talk about more of that during the video that I have. But again, the main thing would be that if these tools are made accessible, they have to not be only made accessible to the city. So for us, as the city of Tallinn, we really prefer that they are accessible also for the planners and the architects, so that they can play around it before they insert this kind of like application into the process, because this again will save the time of the stakeholders. And here is the video of the solution of the prototype. We carried out 7 different automated checks. Here we have like the simple 3D buildings from the city of Tallinn. We have the different layers that we're getting through WMS services, for example, the points of interest like parking lots, fire hydrants, bus stops, etc. There are also all these kind of like nerving zones which come from the utility networks, and also the different models of the sea level rise, because we are next to the sea. We want to see what are the effects of the possible sea level rises. And here we have submitted the different detailed zoning planning models that have the buildable area, the building volume, the transportation layers, the greenery layers, 3 different plannings that are in this area. That you can check it visually. For example, if the bike lanes are connecting within the different plannings, etc. But also these kind of like how are they affecting with the surrounding environment. And here we can see that we don't only have the volumes, we really have the information there as well. So for example, for the buildable areas, what is the height, what is the cross floor area, etc., which is not basically measurable geometrically from these kind of like simplified models. But now going through the checks, first of all, the area measures, we are very quickly getting the idea that what is the total area of the planning area, how much there is the transportation, how much there is the greenery, how much there is the buildable area. We can see that there is a huge gap at the moment, which is not modeled at all. So that in these cases, we can see like it's just this kind of like normal thing to do, and also the overlapping that if one layer is above the other, for example, the transportation area above the greenery area, then there might be some contradictions. Then we're checking if there is enough greenery. For example, 20% is demanded with the master plan, what was produced with the detail plan. Maximum height of the buildable areas, 23 meters is the maximum limit with the master plan. And we can see that all the buildings are according to these kind of like height limits. So there are no problems regarding that. Then again, a simple check, like what is the distance between the buildable areas from each other and from existing buildings, so that if the distance is less than 8 meters, then in the later phases, we have to have these kind of like fire safety requirements that can also in some cases be quite costly. Some cases not, of course, but if we have enough space and it's just a matter of like 1 meter or so, it's easier to just shift the buildable area so that there won't be any kind of problems in the next stages. There is a very simple check regarding the distance to the point of interest. In this case, it was the fire hydrant, but it can be also the bus stop, kindergarten, whatever. At the moment, we're seeing the overlaps with protected areas, so that we can see that this buildable area very, very slightly touches the railway protection area. This could be missable with the naked eye from the PDF, but here the computer is looking at it. And of course, we can produce some kind of warnings from the historical heritage areas, again, the flooding areas, to give the notice that yes, you can build here, but you have to consider that due to being in the heritage area, it might cost more to develop this building because there are additional requirements. And of course, here is the last check about this kind of like cadastral distance, that mostly we require that the buildable area is 4 meters from cadastral border. And in this case, for the red buildings, we can see that there are no cadastral borders presented at all. So we see other kinds of fields that would require different kind of check. And the last slide, of course, I know that I'm terribly over time, but I would try to wrap it up very simply. It's not a very easy thing to do. There are a lot of challenges, like the lack of standardization in the domain. Again, planning, urban planning is perceived as a form of art, and many planners who are architects are just saying that their freedom of art is being now somehow restricted, which is, again, with a point of resistance to change, that they have to understand now that dealing with data is the new form of art, and they just need to adapt. Of course, there are a lot of different stakeholders, and of course also the unmanaged expectations that we cannot do just like this and everything is ready. We have to go step by step and really manage the expectations, what is possible at the moment, and what are the most beneficial things to do to get the most benefit with the simplest solutions. Thank you very much for your time, and I hope that you have some questions for me for the Q&A session.
Brilliant. Thanks, Christopher. I'm sure there's lots of questions there, loads of interesting aspects there, and massive challenge to actually bring all those layers together in there. But I suppose that's the key thing, getting good data together that's that you're able to overlay with each other then to make decisions and make some measurements. So as I said, any questions, please put them in the Q&A function at the bottom of the screen, and we'll deal with those afterwards. So I'm going to hand over to our third speaker, Ian Pyburn from IES, who's going to talk about how digital twins can bring net zero buildings to the next level. So
yeah, Thanks very much, Jamie. And it's good to be here to speak to everyone today. So following on from the first two presentations, I'm going to talk about how you can use digital twin technology as part of the planning and the strategy timelines within construction projects to help get your buildings, communities to net zero and achieve their ESG targets. So my name is Ian Pyburn. I'm a Senior Business Development Manager for IES, and I work with a range of different construction and estates teams to help get the built environment decarbonized using our technology. So to talk about the net zero challenge, and I don't need to explain to anyone on the call today why it's important to get our buildings and communities to net zero, but I do want to talk about the current state and potentially a future state. So what's currently going on in our buildings? Well, after the planning and design process, buildings now have aging BMS systems and a range of different data challenges. I've noticed myself with working with different buildings that even buildings with a BMS system struggle to get actionable information and actionable data out of them. Buildings are becoming more complex and dynamic in nature. And this has really been increased since COVID-19 with the advent of hybrid working. Buildings operation is now changing on an hourly, monthly, or even a daily level. And especially relevant in Ireland and a lot of countries that have the same design system for buildings. Buildings are typically designed for energy, but operated for comfort. So what do I mean there? We have a high design intent. So that in Ireland, that's the BER A rating or LEED Gold for commercial buildings. But people, once they move into the buildings and start using them, can use them in a number of different ways and basically use the buildings as they were not designed. So as planners, as engineers, where do we want to be in the future? Well, as we undergo all of this renovation that we need to get buildings to net zero, we need to ensure net zero technologies, renewable technologies, and building upgrades are being tracked, monitored, and verified. Planners and designers need confidence in the financial risk, the return on investment, the payback period of whatever technologies they're planning on implementing within their buildings. You need to balance occupant health and well-being when you change a building. And finally, for a lot of people just beginning on their sustainability journey, they need to figure out where and how to invest in decarbonization technology. And that's a really important point because on this slide here, there may be people who are just starting out on their sustainability journey, just starting to think about how do I get the buildings I work with to net zero. And a good methodology to use is to focus on two separate items. First of all, digital twin technology and real-time data. So starting with digital twin technology, this allows you unlimited scenario modeling before you make any changes on site. So you now can start to plan digitally of what you're going to do in this building to become net zero. And as a lot of you will know, building physics is so important in regards to that. So say, for example, if you're working with a building and you're doing a simple upgrade, say going from a gas boiler to a heat pump. Building physics is crucial because you need to account for how real weather data will affect that heating upgrade. You need to understand how much heat is lost through the fabric and the walls before you can quantify how much energy savings is from that. And that's why building physics integrated into digital twin process is so important. And it's due to the reliability and accuracy of results. The other side of the house is real-time data. And not just collecting and visualizing real-time data, but getting actionable information from that. Being able to analyze the data, notice trends, notice faults, and get key takeaways that you can take and implement to start the energy saving journey, I guess, within buildings. So for anyone starting off on their sustainability or doing some net zero planning, the advantages of following this approach is it can minimize the cost of decarbonization, which is getting more and more expensive. It can optimize the building and the systems that within that building at a very low cost because you're just looking at the operation of the building, no capex upfront costs. And it provides insurance to your long-term net zero investment plans that you're on the right track and you're doing the right thing towards net zero. Okay, so I know a lot of people on the call today would have heard of IES before, but just for those who haven't, you can see some of our key company milestones on the screen right now, but don't worry, I won't go through them all. But basically, IES, we're a software company. We make software for architects, engineers, construction companies, universities, local authorities, basically anyone who's involved in the design, management, or operation of the built environment. So with our software, we have 15,000 users across the world that would use our software every day on a range of different construction projects. And the only other kind of achievement I want to highlight is this one here. So with our digital twin technology, we have modeled over 1 million buildings worldwide for energy performance. And if you look on our website, we have a lot of different technology. I tried to summarize it as quickly as possible in one slide. But we have a number of tools that can be used for individual buildings. And a lot of people on the call would be used to this top tool here, the virtual environment. This is a tool you would use as part of the design process to do your BER, to do your lead model, BREEAM, and a range of other design calculations at the design stage. And we also have data analytics tools that can hook into BMS for individual buildings as well. Similar to the previous talks, we have urban scale modeling tools as well. So when we need to ramp up or just scale the energy analysis across multiple buildings for local authorities or for universities, we have tools that enable that as well. Some of you may notice that's actually Limerick City there modeled, and we've modeled all of the buildings in Limerick City Centre to become part of the net zero strategy for the whole city. And finally, we have a lot of interactive roadmap tools, dashboarding tools, real-time data platforms. And this has a number of uses in the market at the moment. This is for climate action reporting, decarbonisation roadmaps, or just creating real-time data platforms for different clients. So we have a range of tools that fit into that category as well. But what I really want to talk about today is digital twins. So if you Google digital twin, you'll find 1,000 different solutions doing tens of thousands of different things. So to differentiate ourselves or to highlight the important part of our digital twin, we call it a performance digital twin. And what does that mean? Well, we include the energy simulation that a lot of you would be used to as part of the design process. Again, it's all coming back to that building physics element and getting accurate energy analysis as part of your digital tools. So it goes further than just an asset management or BIM-based tool that collects and stores data. It can also analyze how that building would be in the real world. So again, coming back to my heating upgrade example, if you make a change digitally and then did it in the real world, it should respond and behave like the real building, i.e. the results from our digital twin should reflect real life. So when we work with different clients, and the power of our technology is it can accurately predict the impact of changes digitally before any implementation is done on site. So our technology is crucial if you're trying to get buildings towards net zero. So there's a range of digital twin applications, and that's what this slide here shows. But I'm going to focus on 3 that I think are the most important for getting buildings and communities to net zero. Starting with actioned project performance tracking. So what does that mean? That means when you're doing an energy project, which could be a renovation, could be an operational change, anything that saves money off your energy bills on site, we have a range of different technology that allows you to track, monitor, and verify this. So for those of you that are used to measurement and verification, it uses that kind of M&V style approach for tracking improvements within buildings. And you can kind of see that there in the images on the right-hand side. So this is a real-time data platform. It's updated every single hour. And it allows you to verify the performance savings in terms of energy, cost, and carbon. And it monitors the actual savings. So again, you're moving away from the strategy phase and you're actually looking at when something's changed on site, and it monitors the actual savings. And it ensures investment value afterwards, after the change has been implemented. So as a lot of you know, our technology can model pretty much any intervention we can think of. So I've listed it out here. We can look at different weather and climate scenarios. If you're just focusing on the operation of the building, we can look at operational changes, occupancy changes, tweaks to the HVAC system, lighting schedules. These are usually low-cost operational measures, and that can kickstart your net zero project or net zero strategy. Furthermore, looking at more CapEx investments or technology investments, we can look at fabric upgrades across the whole building. Obviously, any system upgrades, conditioning upgrades, end-of-life upgrades, and obviously adding in renewables, so whether that be solar PV, wind turbines, battery storage. And the big one in Ireland at the moment is actually district energy. There's a big push for more district heating as part of new projects and district heating as part of the design of projects. We can also look at that in combination with our urban scale modeling tools. And finally, the last one to talk about that comes from our digital twin technology is the decarbonization pathways or roadmap. So everybody is asking for this at the moment. Everybody wants some sort of tool that tracks their progress towards net zero or tracks their progress towards their ESG targets. And we have a range of tools that enable this. So these interactive roadmaps bring together all of the detailed improvement scenarios you may have simulated in our other software, and also aligns with science-based targets, whether your clients are looking at scope 1, scope 2, scope 3. And for more commercial buildings, it also aligns with the CREM analysis that some of you will be used to. And this is basically an interactive online cloud platform that we kind of issue to all stakeholders so everybody can see and visualize the progress towards net zero. And importantly, it's not just the energy and carbon these sort of decarbonization pathways look at, it's the financial aspect as well. So again, looking at payback periods, look at it at return on investment, looking for value for money when you're starting on that decarbonization journey is really important. So we've taken account of that with the decarbonization roadmap as well. And finally, I just want to actually talk about a few real life case studies as well, just to show some of that in action. So starting with the action project performance tracking. So we've worked with the University of Liverpool since April 2023. And again, we're looking at the HVAC system and just the operation of the existing building. So we made a number of changes to the operation, upgraded a couple of parts of the HVAC system, and we managed to verify 23% reduction in energy of real savings implemented in the building. And this resulted in roughly 25K of cost savings last year. And then we'll obviously, we're still working with them now. So we'll see what the cost savings is at the end of this year. In terms of net zero scenario testing, and by the way, I should say all of the case studies will be sent on afterwards. I'm just getting a brief overview of them. But a bit of a more local one, Dublin City Council. So we work with the council to model a range of different net zero scenarios. In particular, we work with Dublin City Council looking at their social housing blocks and some of the older buildings in their portfolio. And we want to use our technology to input into their renovation strategy. And I would suggest to everybody to go check out this case study because there's a lot of interesting results that came from it. The first thing was the trade-off between retrofit and demolition. So is it better to retrofit a building to a really high standard? Or is it better to knock down the building and rebuild it to today's energy standards? So we modeled all of that for a number of social housing blocks in North Dublin. And it was a first of a kind project in Ireland because not a lot of these types of projects look at both embodied energy and operational energy, and crucially the trade-off from that. So if you're retrofitting a building, what's the embodied energy associated with all the extra materials? And the same with operational energy. Depending on how high an upgrade you go, it'll obviously use less operational energy into the future. So I would suggest to everyone to go check out that case study. And finally, lastly, the decarbonization pathways and decarbonization roadmap. So a good example here in Ireland of us doing that is with Irish Life. So they basically wanted to see how could their buildings become net zero by 2030. So again, we used our digital twin to model that as part of their planning process. So with that, we tested a range of operational changes and renovation changes and brought it all back into one roadmap aligned to their 2030 target. And it might be difficult to see, but you can kind of see the decarbonisation roadmap there done for each individual building. So that's it for me. Thanks very much. And yeah, any questions, I'll gladly answer them.
Brilliant. Thanks, Ian. Great showcase of some of the tools and through the cases in particular and how they're used by different organizations already. So